All right. I think it's about time that we get the show on the road. So, we are obviously going to be doing. Oh, I'm getting some feedback here. Let me turn this off. There we go. Okay, so I'm going to be doing a update on the snow conditions here in California, around the western U.S., talking about our most recent storms, and then looking at the forecast moving forward. There's been a lot of discussion about what's going on lately, and I thought it would be nice to do a type of briefing here. This will be recorded and uploaded to YouTube for anybody to view afterwards. I will say, please hold questions until the end, because I might answer them along the way. So the way this will work is I'll kind of do anywhere from a 20 to 30 minute kind of briefing, and then we'll have a Q&A session afterwards in which people can ask their questions, and I'll kind of go over them. So I guess we'll start from there and come over to the last several storms. Before I really delve into this, of course, I do want to acknowledge what happened yesterday at Palisades, Tahoe. That very sad situation with the inbounds avalanche and the fatality. Just say that us here at the Snow Lab, those affected are in our thoughts. The community are in our thoughts, and we've been reached out to about whether or not we're going to do some analysis on this event, and whether we can provide commentary. And I think it's just too early for us to really say anything, and we don't really want to speculate. So an awful situation, and our thoughts are with everybody affected, but not really going to be talking much about that. So on to what we are going to talk about. This most recent storm that wrapped up late last night brought in about 9.8 inches of snow. And if you do use our website, which is what you're looking at right now, you'll notice that we always have kind of bizarre looking numbers. That's because we actually do all our measurements in metric to the closest 0.5 centimeters. So if you really want the accurate result, you can do that. But yeah, so we got about 10 inches of snow over the last 24 hours. That brings this storm total up to 13 inches. It actually underperformed compared to what we were expecting. Initially, we had been expecting 1 to 2 feet. Then the models kind of moved things up, and we were looking at 18 inches to 2 feet. But we got a lot less. There's a couple different reasons for that. The first being that we didn't see the onset of heavier snowfall rates until later in the day, when we had initially expected them to occur all day long. The second being that the snow crystal structure was a lot different than what we are used to up here. So with these storms, typically, especially these colder storms, we'll see what we call dendrites, which are those pretty snowflakes. The storm yesterday, we had a lot of fragments of dendrites. We had a lot of needles and things like that just didn't end up giving us a ton of snowfall accumulation. Now, the benefit being we still saw the right amount of water out of that storm, and I'll get into that in a bit. But 13 inches from the storm yesterday. And then over the last 10 days, effectively, going back to the first of the year, we've gone through and over doubled what our snowfall has been so far. We started off the year up until December 31st with 32 inches of snowfall. In the last 10 days, we've had 39 inches. So we're doing better than we had for the first couple months of the season. And I'm going to zoom in on the plot down here at the bottom of the screen. You can kind of see that when we zoom in. You can see this long period, late October, November, where we didn't get much. Eventually got more snowfall in early December, but it kind of flatlined since then. Really, this period in early January has been the most consistent storm systems that we've seen so far this year. So since the first, our first storm was January 2nd to the 3rd. We saw 11 inches out of that one. The second was the 6th through the 7th. We saw 13.6 inches out of that one. And then this one, we've had 12.8. So doing a little bit better in accumulation over the last several days as far as that goes. So the one kind of caveat to this being, of course, we're more so worried about our snow water equivalent, right? We want to know how much water is in the snowpack for our uses rather than the overall snowfall. So I'm going to go ahead and bring that up on here. That's precipitation. There's snow water equivalent. And this is what it's looking like so far to this date. You can see the numbers on the top right there. We're 53% of average for our snow water equivalent here at the Snow Lab, and only 20% of what we would expect for our peak SWE, which typically occurs right around mid to late March here at the lab. So not doing so well overall. That being said, we are 6 weeks into our wettest period. So our wettest period typically goes from December through February, excuse me. We're about mid-January now. So we've gone through about half of our snowiest period, and we've come up a little shy. It's getting to a point where we're a little concerned, but it's not necessarily time to panic. We still have another 6 weeks potentially to really buffer our snow up. But when you look at this plot, that blue line there that shows our median, the second half of January supplies a lot of our snowpack and the water in that snowpack. We generally kind of taper off in early February and then see a bump late February and then a little bit more in March. But really, the next 2 to 4 weeks are going to be vital. If we get through those weeks and we're still well below average, it's going to be kind of a problematic story as far as our water is concerned. Something that you will notice if you're visiting our website on a regular is that oftentimes two numbers don't match up, and that's our precipitation to date numbers. So we have our snowfall to date, which is 60% of average, but we have 77% of average to date for our overall precipitation, and that includes both rain and snow. And that's because earlier this year we had a series of storms come in that were warmer, that dropped rain instead of actually accumulating snowfall like we might ordinarily see. So we do have higher precipitation, a higher percentage of precipitation to date, but snowfall is still lagging behind. Now, I'm going to go through over here to the next tab. That was primarily the Snow Lab. If we're talking about the state of California, this is the California Data Exchange Center from the California Department of Water Resources. It's a great tool for anybody looking to really check out the numbers around the state. So these numbers were just updated by DWR. This uses automated weather sensors throughout the Sierra Nevada. There's a lot of them, I think about 250 throughout the mountains. You can see here in the northern portion of the state, we're at about 48% of our average snowpack to date. Here in the Central Sierra, 46%. Down south, much worse at 31%. Overall, the statewide summary at this point, we're 42% of average, which, believe it or not, is much better than we were at this time yesterday, which we were only at 37% of average. So we've bulked up 4% in the last day. So the challenge being that we are seeing these storms help our snowpack a little. Like I just mentioned, we saw 4% increase in our snow water equivalent from these stations. But the problem here is that these storms aren't necessarily big enough to make up for the deficit that we've already encountered through the early season. Going forward, we really want to see big storms. We need to see 3-4 inches of precip with some of these storms to really start getting us back close to average. And we're just kind of getting storms to keep us basically where we are at that 30 to 40% range. Moving on, if we decide to look at the state as a whole, again, so these plots show us what we would ordinarily expect for our snow water equivalent throughout the state over the course of the year. You can see the months down at the bottom there, December through July. The red line at the very top is the 1982 through 1983 water year, which is traditionally kind of heralded as the maximum year that we've had for this network. We also see that light blue shaded area. That's what we would expect out of a normal year. And then we have this thin blue line at the bottom. That's our 2014-2015 minimum, the driest year on record. I did add one other line. It's that faint green one that you can see there. That is from last year as a basis of comparison. You can see there was a few times that jumped up above even the 82, 83 year. But realistically, what we're looking at here is that fat blue line with a number next to it. So we have northern, central, southern parts of the state, and then the state overall. And you can see that as far as our April 1st average is concerned, not looking great so far. In fact, up until only the last few days, most of these numbers were even below our driest year of 2014 to 2015. Now, though, we're at 21% of our April 1st average in the northern central portions, 14% in the southern portion, and 19% overall in the state. I do want to mention, for those that aren't familiar with why we use the April 1st average number, that's traditionally when the snowpack is at its deepest. That's when the most useful measurement for determining our water supply moving forward into the late spring and early summer. And the numbers that most often are used to model our reservoir inflows and releases. So that's what we're looking like around the state right now. If this is another plot, another way to look at this, just again, really looking at where we're at with our overall season. We're getting better, but still shy of where we want to be here in the state. Now, the benefit that we had last winter from that big winter is still being seen in our major reservoirs right now. So this graphic shows our water storage at selected reservoirs around the state. Our historical average is in that green horizontal line on each of these plots, and the blue bar is showing us where their current storage is. So you can see Shasta, Oroville, Comanche, and a lot of these still have above average storage in them thanks to that abundant water last year, and we want them to stay there. The challenge being, if this year does end up dry, we may end up having to use some of that additional water in those reservoirs to make up for what we're not getting. So we really want an average, if not above average year, to make sure that we can carry forward the benefit that we saw last year and not have to have it go towards replenishing the poor snow season this year. If we kind of zoom out a little bit and talk more so about the Western US, that is a little bit scary. There we go. That's this year. So we're going to look effectively at snow tell stations. And so what these are, each one of these little dots is a snow telemetry station that takes various measurements of the snowpack, soil conditions, atmospheric conditions throughout the western United States. These are run by the USDA Natural Resources Conservation Service. And you can see on the bottom left here, we have this legend that shows color coordination between the dot colors and where we're at in terms of our snow water equivalent percentage. By and large, this is not looking great, right? We see a lot of 50 to 69%. A lot are red at below 50%. We do see some better conditions in Utah, in the Wasatch and Uinta, as well as in the Colorado Rockies, a little bit up into the Blue Mountains as well, but not looking great as far as these stations are measuring. If we step back and look at the basin conditions, this is what we're looking like. This is vastly improved actually over the last week, but we're still looking at some below average conditions throughout the Western US. In fact, there's only realistically a few of these catchments and basins that really are above average. This one here on the Oregon coast, the northern Oregon coastal area, that's at 733% average. That is likely a sensor error. I don't believe that it's that high. It might be, but that's probably going to be a sensor error. Otherwise, we see a few through Nevada that are above average, a couple around Great Salt Lake, and then some others that are kind of dotted here and there. Again, for comparison, if we look at this time last year, we can see a much different picture. Everyone was above average. If we talk about the Tulare Buena Vista Lakes Basin, 287% of average. Here in Mono Owens, almost 400% of average at this time last year. So we are definitely on the dry side. And if we want to go back to a year that had similar or worse conditions, we have to go back to 2018, where conditions at this time were worse. Luckily, later in that year, we did end up getting a little bit more precipitation, and these areas bulked up to about to give us more. That being said, we did not actually reach our average last year or in 2018 as far as our snow water equivalent. In fact, if I recall correctly, I think we got to about 2/3 of it. So we are dry this year, but things have improved with the storm tracks that have gone through. That's kind of the common theme here. Now, that brings up what we're looking at for the next several days. Those are kind of the general conditions as far as what we've seen. It hasn't been a great start to the year. We have been getting consistent storms now. What are we looking at moving forward? And we do have another storm on the horizon, right? We have one coming through this weekend, Saturday into Sunday morning, a little bit in Sunday morning, but mostly Saturday and Friday evening. But we can see overall the timing of this mostly coming in late Friday, really bulking up and becoming substantial Saturday morning through midday and evening, and then moving out later that night. This system is pretty well agreed upon on the models. If we really want to look at overall totals right now, we can kind of come through and look at that. I should mention before I go on to a different map, this is my first time doing this. Apologies if I'm not explaining everything, at least in this format. So any type of precipitation, you want blues. Blues are going to be snow. Greens and yellows are going to be rain or heavy rain. If it's heavy snow, it's going to be kind of this magenta color. And then we have freezing rain and sleet, which are things that we don't typically deal with too much here in the Sierra. But we are seeing similar timing on this storm from the various models. If we're going to be looking at snowfall accumulations for this event, they're pretty optimistic again. I'll go ahead and zoom in a little bit closer to the lab here. But we can see broadly, Northern California is looking like it's probably going to get the most snow out of this system again. That's not necessarily uncharacteristic. The storm track this year has been much further north than it was last year, which is why we're getting reduced amounts of precipitation. So Northern California is probably going to get a lot of this precipitation, the bulk of it. But as far as snow totals around Donner Summit, where the lab is located, we're still looking at 22 inches according to this model run. I would say probably 1 to 2 feet is a safe bet based off of the models that are out right now. This is the GFS, which is the Global Forecast System, or the American kind of short to moderate range model. Let me see here. If we look at the European model for the same period, it's showing about 18 inches for this run. Again, we were expecting larger numbers out of this most recent storm, so I'm inclined to think that it'll be a little bit lighter than this. I think the forecast of 1 to 2 feet is probably pretty likely at this point. But obviously, we still have a couple days, roughly 36 hours for those models to wiggle around a little bit before we get into that position. So if we start talking about what happens beyond this weekend, I'm going to again zoom out here to our regional perspective in the southwestern US. So we're going to take another look here at precipitation. So this is type and rate. So again, darker blues are going to be heavier snow, darker greens and yellows are going to be rain. But as we move forward in time, there's our weekend storm. And then we're not seeing much coming through. Earlier this week, late last week, there was some kind of argument between model runs and even the models themselves that showed that we might stay a little bit wet. That is not at all the case with the most recent runs, and I think we're seeing that here. There might be A little bit of moisture that comes through. You can kind of see that here into Northern California midweek next week. But by and large, it looks like we're going to be drying out. I will say the scrolling that I'm doing now, you can see I'm out up here at the top of this scroll bar. You'll see numbers. Those are hours away from the model run. So basically 240 hours, which would be right about here, is 10 days. And we see a little bit of precipitation there. That being said, it's not something to count on. Anything below the 7 to 10 day window is really not trustworthy as far as specific locations of precipitation. So we have this weekend storm, maybe a little bit of precipitation in Northern California midweek next week, but other than that, drying conditions broadly through the state and the Western US, as a matter of fact. So that's kind of what we're looking at over the next couple weeks. If we want to move on, I'm going to take us to the North American Multi-Model Ensemble. So this is going to look effectively at what we're expecting a little bit further out, 1 month out and then 3 months out for what we can expect out of the rest of this precipitation period moving forward. So we're going to take a look at 1 month first, and we're going to look at precipitation rate. So looking forward for a month, this is a graph showing basically anything green is going to be above average precipitation rate for that period. Anything brown is going to be below, and gray is kind of neutral. But realistically speaking, we're looking pretty average, more or less, here in California, below average in a lot of the West at that point. So it looks like we might be drying out overall. So this is consistent with what we're seeing in the weather models right now. If we really want to look further out as far as what we're expecting for the next 3 month period, this is, again, what we're seeing basically through April. We are seeing dry characteristics with these models throughout California, most of the West. But that being said, again, these are what I like to call guidance. These are guidance, not a set and fast rule. Right now, it's looking like we're going to be dry. We could see increased periods of storms that might leave us a little bit wet. So these are definitely something to consider, but not the end all be all by any means for this period. So, I guess realistically, just to kind of recap everything that we've been talking about, start of the year exceedingly dry. We are seeing now quite a bit of, or we have been seeing, I should say, a lot of precipitation coming through on a regular basis. With that being said, that's expected to stop over the next week to week and a half. So moving forward, we're going to see drying. We're going to see probably not too many storms outside of the one that's occurring this next weekend, where we could see another 1 to 2 feet of snow. Hopefully, I didn't rush through things too much and bore you all. What I will now do is give you guys the chance to ask any questions that you might have. Manola brings up a good point. If you could please just raise your hand so that when I'm looking at the participants, I know who has questions and who doesn't, and then I can unmute those that do. So I'll start with Manola here. Let me go ahead and ask you to unmute.
Hi. Yeah. Thanks for the presentation. It was really helpful. Yeah, I'm just curious, when it comes to these forecasts, is there anything that you can say in regards to how we predict, future avalanches during storms like this? I'm just curious, with the one that just happened, how far out are we able to predict avalanches in general? I don't know if they're a bit of a challenge or if we have a good ability to predict them. And then, yeah, is there anything that you can say with what you just went over with us about what that could look like?
Absolutely, yeah. So realistically speaking, the bulk of avalanche forecasting is going to be based off of observations. A great group to follow for that type of information is the Sierra Avalanche Center. They do absolutely great work. But really getting to whether or not we have avalanche conditions is based primarily on teams going out into the field, digging snow pits, and actually doing observations of whether or not there are weak layers in the snowpack. That's where our focus really lies with a lot of the concern regarding forecasting these types of events. And when we talk about the potential for future avalanches, we can kind of look at that based off of weather forecasts. I would say, realistically speaking, a maximum of 7 days, because we can identify things like temperature periods and calm periods that may allow for weak layers to develop. We can look at things like strong winds and potential, what we call potential wind loading events, which is when it's snowing or might be blowing snow across the surface that might be transported to an area on the opposite side of a mountain range that could then develop a large area that could then avalanche. So it's kind of a combination of I really identifying whether or not conditions are persistent or exist in the snowpack already, and the weather forecast over the next week. Beyond that, it's a little difficult. Rachel, it looks like you have a question. I'll go ahead and allow you to unmute.
Yes. Hey, Andy, thank you for this. This might be a little repetitive, but it's just also a follow-up. Can you help us just kind of make sense of, this poor Western snowpack that you just described and how that was followed by this massive dump of heavy wet snow from the current storm that made this avalanche much more likely? If you could just give some context and connect the dots for us on this poor winter snow, weather whiplash, and climate change kind of all playing a role in here. Yeah, I might have some follow-up questions if that's okay for later, but let's start there.
Yeah. So I'll start by saying I don't necessarily want to speculate as far as what made yesterday's avalanche happen. The best people that are going to have the most detailed information regarding that are going to be the Palisades Tahoe Ski Patrol. Their ski patrol does all they can to ensure that conditions are as safe as possible, and they're going to be the ones that really have a lot of detail and analysis on what specifically caused that. I can say that typically speaking, when we get a slow start to the year as far as our snowpack is concerned, that can occasionally allow for weak layers to develop in the snowpack. So when we have periods where we might get precipitation and then we get a melting on the top that develops kind of a crust, and then we do have additional snowfall that falls on top of that crust, that can present issues as far as creating a persistent weak layer. So, realistically speaking, the poor start to the season doesn't help. There are other local recent conditions that don't help either. As far as what the terrain was, it is unfortunately avalanche terrain up in that area. That's why KT22 is one of the best and highly regarded lifts in the country, if not the world. It's because it has terrific terrain for expert riders and skiers. But as far as climate change impacts on this, I think that the variability that we see in early season snowfall now is problematic. Because we do have periods where it'll go back and forth between getting snow and then having rain fall on top of it and potentially creating a layer of ice. We do have periods where we'll go long times without any additional snowfall, and we'll go from one temperature extreme to another that'll allow things like hoarfrost to grow on the surface of the snowpack, which will develop as a weak layer. So it's hard to say exactly what led into the conditions that caused the avalanche yesterday. Again, I want to defer to Palisades Tahoe with that because they're going to have the best information. But the late start to the season that we've had and the lower than average snowpack conditions certainly didn't help. Any other questions? If anybody has anything specifically that they'd like to chat about, I can go back over some of those weather plots, even if it's just how to interpret them or where I'm getting my data. Happy to put that out there. Other than that, I will say, I'll kind of hang out for a couple minutes. Apologies for the hoodie today. It's a little informal, but it was only 5 degrees Fahrenheit this morning at the lab. So it's been a day of layering up to make sure that it's not too terrible. Yeah, Rachel, I'm not seeing anybody else with questions. So I guess if you want to go ahead and shoot. Let me see if I can unmute you over here. There you are. Had to scroll down to you, sorry. Again, if you raise your hand, it puts you to the top of my list so I don't have to go searching for you. Rachel, I asked to unmute. Hopefully that
Thank
worked.
you. Sorry. No, I'm here. Yes, it did. I was just wondering about what your take is on just this record warm ocean temperatures and how they played a role in just kind of this winter's extreme weather, especially in the West.
That's a good question. I think as far as record warm ocean temperatures are concerned, unfortunately, that seems to be a trend that we're seeing a lot. The El Nino certainly doesn't help. I guess kind of the complicating factor is that through a lot of parts of the Western United States, we don't necessarily have high correlations to things like El Nino. There seems to be a misconception that El Ninos always mean wetter winters, especially for us here in California. And of the last 2 decades, the 7 El Nino events that have happened there, 2 were above average, 2 were below average, and 3 were right about average. Here at the Snow Lab, when we do get El Ninos, 5 have been in our top snowiest years of all time. And then we've also had 4 in our least snowiest years of all time. So it's hard to say. As far as figuring out what the record warm ocean temperatures are contributing to this out here in the West, that's really going to probably be best for an attribution study when we go back and look at the season as a whole and try to remove the climate change signal from it. But that being said, the warmer than average temperatures that we have had at the lab early this year gave us a lot of precipitation that came in as rain that would have ordinarily been snowfall. And so I think, the precipitation percentage being higher than our snowfall percentage, when last year the opposite was true, is very much, at least in part, due to that. And so, unfortunately, it's kind of more of the same. There's the ideas that we have about how these warm temperatures will affect things, but in order to really get good answers on how they affect any one particular season, we'll have to go back into an attribution study. All right, it looks like Monica Woods has a question. I'm going to unmute you.
Hi there. Just wanted to go back real quickly to the cold temperatures post precipitation event when we have these below zero overnight lows. As we know, snowpack is one thing, snow water equivalent another. What kind of impact are you seeing with the snow water equivalent, again, post precipitation event, to how that may actually increase the evaporation rate of some of that water content in the existing snowpack?
Yeah, that's a good question. So when we do have the what do I want to say here? I guess after snow has fallen, it's a little bit jargony, but there's 2 different ways to talk about this. Once the snow's on the snowpack, it's snow water equivalent. When it's still falling, it's snow to liquid ratio. But regardless, when we have drier snow, we have that kind of those colder temperatures contributing to that. The precipitation we get is the precipitation we get. But you made a really good point about evaporation and even sublimation, which is the removal of moisture without it ever turning into liquid, right? So when we do have that dry, light snow and we have strong wind events, we can see higher evaporation and sublimation rates versus a denser snowpack. Oftentimes, when we think about it in terms of surface area, less dense snow is going to have more surface area exposed. typically, and so that means that it's going to evaporate a little bit quicker. But it really just depends on what the following day's characteristics are. If we have really low temperatures following the storms for a longer period, we're going to see a lot more evaporation and a lot more, a lot more sublimation and potential evaporation. If we see warmer conditions that allow for that dry snow to really become more dense, then it might not be as much of an issue. So it's kind of a combination, again, it doesn't matter if it comes down as 2 feet or 8 inches, it's going to be the same liquid water or snow water equivalent regardless. It just depends on how the atmosphere interacts with that. And a lot of that just depends on the weather in the following days. Hope that helped. I have another question from Chris. I'm going to go ahead and unmute you.
Yeah, hey Andrew, really appreciate you doing this. This is super helpful. You talked about it's not time to panic yet. Let's say we come back here in a month and we see a new set of numbers when it comes to whether it's the April 1st average or what we're seeing in the snowpack at that moment. What would cause you to panic then? I mean, what threshold should we be extraordinarily worried when we come back in February?
Yeah, I mean, realistically speaking, I think the concern now is we're drying out again. And as we saw before, we have, and I'll go ahead and share this again, my screen again. When we look back at this snow water equivalent chart, so much of our snow water equivalent comes in this second half of January. And the forecast now is showing us that we're not necessarily expected to get much, if any, precipitation in that period, other than what's going to happen this weekend. So moving forward to the February 1st snow survey, it's quite likely that we'll lose some of the benefit that we've gained in these recent storms as far as percentage, right? We're not going to lose the water, but we're sitting at, here at the lab at 53%. And if we stay at that while we're supposed to be getting deeper, then it's quite possible that we end up at 25 or 30% again. And that is when we start to become a lot more concerned, because coming back from 50 or 60% is a lot easier than 25 or 30%. And I think, if we get to the February 1st measurement and we're at 25 or 30, it becomes incredibly unlikely that we'll recover at that point to at least get to normal. And at that point would more likely be that we're going to figure out how much damage control we have to do as far as utilizing that extra water in our reservoirs. So getting to that February 1st point, if we haven't seen additional precipitation and then we're looking at the forecast and we don't see more over the next week or two, that's when things become a lot more concerning, because by that point we should have accumulated the vast majority of our snowpack. I hope that makes sense. Let me go back here. I'll stop sharing that. All right. I'm going to lower your hand, Chris, unless you have a follow-up, then you can re-raise it. We do have another 19 minutes if anybody else has questions. If not, we can conclude. Or if any, I do see a few colleagues on here too. If any colleagues have anything they'd like to add, they're more than welcome to do so. All right. Well, I'll make one last call for questions. Other than that, I'll just start wrapping things up. I want to thank everybody for joining me today. I hope this was informative. If you have suggestions on how I can make this better in the future, how we can make this better in the future, let me know. This will likely become more of a regular thing, just in terms of either a big forecast coming up to try to get ahead of it and to answer as many questions as I can before a big storm, and maybe potentially doing the same thing as I'm doing today, whereas we've had several successive storms, just recapping where we're at. So expect more of these moving into the future. If you have suggestions on how I can make them better, I would love to hear them. Other than that, thank you very, very much for attending. I really appreciate it. And Look forward to speaking with you guys more in the future. Thank you very much and have a great rest of your Thursday.